Hello everyone, today we're going to be looking at the 2026 F equals MA exam problem 17. This problem is about a ladder and it sliding down a wall. But first, I want to start off with the physics joke of the day, which is, I'm currently reading a book on anti-gravity. It's impossible to put down. So, let's start by reading this problem. A ladder is leaning against a vertical wall. The ladder is a uniform rod of mass m and length L, and both the wall and the ground are frictionless. The ladder is released from rest from an almost vertical position and begins to slide. What is the speed at the point of the ladder that is in contact with the floor when it is a horizontal distance square root of 3L over 2 away from the wall? So first, we can see this keyword frictionless, which means that there's no energy lost. And since there's no energy lost, we know that we can apply conservation of energy. So conservation of energy states that E initial is equal to E final. Let me actually draw a diagram of this. So we have this ladder here. The length of the ladder is L, and it starts at a height of L, right? Because it starts at almost vertical. And let's call this angle here theta. So using this right triangle over here, we know that this vertical length is L sine theta, and this horizontal length is L cosine theta. Now, after this naming of the sides in terms of L and theta, we can expand on this E initial and E final. So E initial is going to be equal to the potential energy because there's no kinetic energy at initial. And this is going to be equal to U final plus K final. Now, U initial, we know that U equals mgh, right? But here, you might be tempted to say that it's equal to mgl. And I actually made this mistake, but why is it not true? It's because you have to make sure that it's in the center of mass, because that's where like the center of mass is the point that you can just use as considering something as a point mass. But let's say if it's right here, right? That's not where the center of mass is. In fact, that's just the tip of the rod. So since it's a uniform rod here, it has to be in the middle. And so this is not true. It's actually mg times L over 2, because that's where the center of mass is located. And that's U initial. Now, U final is also going to be equal to mgh final. And mgh final is going to be equal to the middle of the rod after it has fallen. So this height. And this height is going to be equal to L sine theta over 2, because this is L sine theta. So we get L over 2 sine theta. I just distributed it a bit. And so we know that from this equation, U initial equals minus UF equals KF. So, and we can subtract this from this. MGL over 2 gets factored out. So MGL over 2 times 1 minus sine of theta is going to be equal to 1/2 I omega squared. And make sure to know that this is rotational kinetic energy instead of just translational, because the rod is rotating around this corner, right? Like, it's not pivoting about the corner, but it is rotating. So the kinetic energy is rotational. Okay. So after this, we can use the fact that we want to try to find V, right? So it's asking what is the speed, right? So it's trying to find V. And from V, what can we get from V, right? We can use kinematics. We can use V like rotational. Oh, sorry. I'm gonna say linear, sorry. Linear and rotational. And we can also use like momentum, right? So which one best suits our case? Well, first of all, it's not linear because the whole thing is rotating. Well, for momentum, it doesn't, we don't know any speed, and it's not like a collision, so not momentum, so we can use rotational. And the formula for that is V equals R omega, right? So in order to try to get V, we have to try to find omega, or find omega in terms of other variables. So since we already know R, right, it's a constant, then we just need to find omega. So, and back to this equation, we see that omega is already in our in this equation. So let's try to get an expression that equals omega. So first we can multiply both sides by 2. So these cancel out. And divide this by I, right? And we also know that for yeah, so we also know that the I, right, for a uniform rod, we know that the moment of inertia, I, is going to be equal to 1/3 ml squared, right? So we're going to divide this by 1/3 ml squared, and that's going to be equal to m's cancel out, l's cancel out, 3 goes to the top. So omega squared equals 3g over L times 1 minus sine theta. Now after this, and you might be wondering, right, if they already give us that the horizontal distance is this, so this is equal to square root of 3L over 2, right? Why don't I just find what theta is? Well, it turns out that this problem was much more complicated than the American Association of Physics Teachers intended. So it's actually more difficult than just simply sliding down the whole time. But I'll get into that later. So after we get this, we can just plug in a sine theta, right? So let's just try to do this first. Square root 3 over 2 times L equals L cosine theta. So cosine theta equals square root 3 over 2. And this is a standard result of theta is going to be equal to 30 degrees, right? So theta is 30 degrees over here. Now the sine of theta, sine of 30, right, equals 3g over L, 1 minus a sine of 30. And we know that sine of 30 degrees is 1/2. So 1 minus 1/2 is going to be 1/2. And that's going to be equal to 3g over 2L. So omega squared is going to be equal to 3g over 2L. Okay? So after this 3g over 2L, right? Then we can try to use V equals R omega, right? So omega equals now the square root of 3g over 2L. But the problem is we don't know what R is, right? So in order to find R, there's 2 ways, okay? 2 ways to find R. The first one is using calculus. And I know some of you guys might not know calculus yet, so a second way is called the ICR, or instantaneous center of rotation. So first, the way that uses calculus. We know that this is L cosine theta, right? So we know that x is going to be equal to L cosine theta. That's the distance. but the speed of that, the distance from the center, right? But the speed at that point, we take the derivative with respect to time. So dx over dt is going to be equal to L, which is a constant, times negative sine theta, right? Because that's the derivative of cosine theta. And we have to make sure to use the chain rule. So we have to add d theta over dt. Now, dx over dt is equal to v, right? It's going to be equal to L. Now, d theta over dt is omega. So negative L omega sine theta. Now, v equals r omega, right? So r is going to be equal to negative L sine theta. But in this case, the negative doesn't matter because it's simply the direction of v. So r is always positive because it's a distance. So r is going to be equal to L sine theta. Now, there's also this other way called the ICR, which is a bit less common. So basically, the concept is that there's this point of rotation that every sliding object is instantaneously rotating about. And it's just that it is along the line that is perpendicular to the moving direction. So we know that these two ends are moving in these directions respectively. So in order to make perpendicular, right, we can make these perpendicular lines and they intersect at this point, right? And this point is called the instantaneous center of rotation. And it has coordinates x equals L cosine theta, y equals L sine theta, right? And if this point, right, we're trying to find this point, the distance, right, the r is just going to be L sine theta here, L sine theta. So those are two ways to find the r, but yeah, r, you both get the same result, which is good because it verifies it. So v is equal to L omega sine theta. Now, I don't care about the negative sign because I'm just trying to find the magnitude, which is equal to L times the square root of 3g over 2L sine theta. And plugging in theta equals 30 degrees, we get that it's going to be equal to square root of 3gl over 2 times 1/2, which is equal to what? Square root of 3gl over 8. Now, if we look at the answer results, right? The answer choices, sorry. They all have square root of gl factored out. They have a decimal, right? So we'll have to do some calculator calculations. It's going to be equal to the square root of 3 over 8 times the square root of gl. So if I plug that into my calculator, here, the square root of 3 over 8. So 3 over 8 is going to be equal to the 0.375, and the square root of that is going to be equal to 0.61. So this is approximately equal to 0.61 square root of GL. And that corresponds to answer choice D. So D is the answer, right? Well, in fact, it's not that simple. This is actually one of the, in my opinion, it's one of the hardest problems on the exam. Not because the solution, this solution is particularly hard, but because in order to prove that this is technically not right, you have to use a lot of calculus, and it's going to turn out very complicated. But I feel like this is very important because in physics problems, we often have to consider every single scenario, because even the problem makers, right, American Association of Physics Teachers, even they forgot that this was actually more complicated, and that the ladder actually detaches from the wall before it gets to 30 degrees. So let me explain. So there actually exists an angle that, the ladder starts here, right? But it actually turns, right? It turns this way. It goes from here to here to here. But at one point, it stops touching, right? It stops touching the wall. So it doesn't stay on the wall the whole time, which kind of changes how we, like the method we used, right? Because now it's way more complicated because it doesn't just have a constant sticking to the wall. And especially because, over here, we assume that there's this normal force, right? Let me call it NW, normal force from the wall, which causes acceleration, right? It equals, actually, let me call it mx because it's in x direction. It equals max, right? So we assumed that there's this max, but if the ladder suddenly stops touching the wall, it won't accelerate. So we're trying to find when n of x is going to be equal to 0, right? That is when the velocity will stop changing. So now n of x, right? We can start by trying to find a of x. So yeah. So first, let me, sorry, this is kind of complicated, but let me move this. Oh, sorry. Wait, what? 2? Okay, sorry. Let me crop this out. So, this is the previous solution. Okay, so, in order to find n of x equals max, right, equals 0, we need to know that, we need ax to be equal to 0, right? And we know that a is equal to dv over dt, right? Velocity over time. And we know that that's going to be d over dt of v. And v, we already found from our previous calculation, right? We know that v equals negative L omega sine theta. So negative L omega sine theta. And using this, we know that a is going to be equal to d, so negative L, right? That's constant. And so we have omega sine theta, but omega and sine theta are both things that can change, right? So we have to use the product rule here. And so first we have omega and sine theta. I'm going to use different colors. So omega, the derivative of omega, right, with respect to t is going to be d omega over dt, which is equal to angular acceleration, right, times the sine of theta, plus, now we have omega times sine theta, right? We have the sine theta derivative. So sine theta derivative is equal to cosine theta. But we have to remember that there's a theta here, so we also have to do implicit differentiation, chain rule, d theta over dt. And that's equal to omega itself. So omega squared cosine theta. Yeah. So after we find this, there are some things that we don't know, right? So we don't know what alpha is. We know what omega is, but we don't know what alpha is, right? We need to find what alpha is. So in order to find what alpha is, we can start by stating what we know. We know that alpha is equal to d omega over dt, right? And hey, we know what omega is, right? We have an expression for omega somewhere. See? Omega squared equals this. Okay, omega squared equals 3g over L times 1 minus sine theta. So what we can do right now is to take the derivative of both sides, right? Because we want to get d over dt, this. Take the derivative with respect to time. So d over dt of omega squared, what is that equal to? Well, I'm just going to solve for right now. So it's going to be equal to 2 omega d omega over dt, right? It's going to be equal to, now 3g over L is a constant, right? What is 1 minus sine theta? So I'm, the derivative of that, yeah. And so we get this. And after this, d over dt of 1 minus sine theta, right? 1, that's a constant, it cancels out. Negative sine theta, it turns into negative cosine theta, right? So negative cosine theta. And so d omega of dt is alpha, right? Oh yeah, and don't forget we still have to do d theta over dt over here because of the chain rule. So d theta over dt, what is that? That's also omega, right? So omegas cancel out. Here. 2, wait, it's fine, I'll keep that. So 2 times alpha is this, right? Now we get that alpha is going to be equal to negative 3g over 2l times cosine theta. And so we can plug this into our formula, right? It's going to be equal to negative L times negative 3g over 2l cosine theta sine theta plus omega squared. Now what's omega squared? It's just this, right? And I'm lazy, so I'm just going to copy this. Okay. Wait. Here. Yeah. Yeah, 3g over 2l, 1 plus sine theta, and that's omega squared, right? Times cosine theta. And we know that's going to be equal to 0, right? That's our whole point of doing this whole calculation. We want to find when a of x is going to be equal to 0. So here we can do some cancellation, right? L, L, and L. So now we have the negative and negative, right? We cancel the negative. This becomes positive. This becomes negative. So 3g over 2 cosine theta sine theta. And since this is negative, we can bring it over to the other side. It's equal to 3g 1 minus sine theta cosine theta. Cosine theta cancels out on both sides. Here. Cosine theta cancels out on both sides. So we have this, right? 3g, I'm going to multiply by 2 on both sides. Wait, sorry. Divide by 3g on both sides. 1/2 sine theta is equal to 1 minus sine theta. So now 1/2 sine theta plus sine theta, because we moved the sine theta on this side, right? Let me use a different color. Plus sine theta is equal to 1. And now finally, since everything cancels out, we get that 3 over 2 sine theta is equal to 1. Sine of theta equals to 2/3. And that is our final answer of when the ladder will detach. Now, at this angle, right? So what is this angle actually in degrees? Well, if I pull up my calculator, arc sine, right? Arc sine of 2 over 3 is 41.8, right? Theta is approximately equal to 41.8 degrees, okay? And so at this angle, right, it actually happens before we get to 30 degrees, because if we think about it, it starts at a higher angle, right? Theta is higher and it gradually decreases. But if it already leaves, the ladder already leaves at this angle, right? So then the velocity won't change after this. So in order to find how to do this, right? Then we can just plug it back into the same formula, right? We see that V equals L omega sine theta. So V equals L omega sine theta. And we copy the same exact thing. I'm just gonna copy this. Oh, sorry. I'm gonna duplicate this, and we're gonna put it on this side. Wait, hold. And hold. Let's put this here, and now theta isn't equal to this. Theta is, so let's just put that sine theta is equal to 2/3, right? Oh, wait. Yeah. Sorry, because this part is 1 minus sine theta. We can't leave that part out. So it's actually square root of 3g over L, 1 minus sine theta, and then times sine theta. And sine theta is 2/3, right? So then this thing is going to be equal to, finally, it's going to be equal to square root of 3g L, 1 minus 2/3 times 2/3. So 1 minus 2/3 is 1/3, right? 1/3 times 3, that cancels out. And that's just going to be the square root of GL, right? Times 2/3. Now, what is 2/3? Well, 2/3 is approximately equal to 0.67. And while this isn't an actual answer choice, it's extremely close to answer choice E, right? And since this is actually the theoretically correct way of doing this problem, even though maybe AAPT didn't, even probably no one during the exam did this whole thing, but AAPT still accepted this response. So both D and E were considered correct. Those are your 2 correct answers. Okay, thank you guys for watching, and I hope you enjoy this video and learned something new. Please consider subscribing because I spent like 4 hours trying to prepare for this video. I had a bunch of drafts that were just not perfect, and I had to re-record everything. So I really appreciate it if you subscribed, and yeah, check out my other videos as well if you're interested. Yeah, thank you.